Hi, ladies and gentlemen. This is Mr. Green. Uh, I'm going to be giving standardized test this week, so I probably am not going to be able to be at Class Connect. So I'm making this recording for Class Connect so that you can see what's going on, and then I'll send it out to you in advance, and we'll be able to go from there. So what are we looking at? Well, we're looking at the same things that we've been looking at for last week, which is to deal with conditional probabilities. And what we're going to look at today is this one lesson, 5.03. Now, this 5.03 is a little bit more difficult than the other ones where we were just dealing with probabilities and it made sense. You could put balls in a bucket and draw them out, and it made sense and you could do it. Here we're looking at things that are a little bit different. So anytime I've got discrete random variables, okay, we know we can find the mean, and all we got to do there of the variables is just find the average of them, right? We can find the standard deviation. There's a formula for that. But you know what? When we're looking at what is uh, the mean and the variance of the value of a series of numbers, we get a little bit different. What we're doing here is we're taking the x value and we're multiplying it times the value of that x value. Okay? Does that make sense? I don't know. Here we're taking the standard deviation. We're taking the x value. We're subtracting the mean of that x value. We're squaring it and multiplying it times the value of that x value. What are you talking about here, Mr. Green? The value of that x value. Well, what we're actually doing is making what's called a weighted mean. Okay? Here we've got X is going to be the number of courses for which a randomly selected student at a certain university is registered for. It's just the number of courses they're registered for. Okay? So if we select a student and they say they're registered at 3 courses, there is a probability of 0.09. And so what we're going to do is we're going to find the weighted mean of doing this. So what I'm going to do is I'm going to take 1 times the weighted mean, 0.02. And I'm going to add to that 2 times 0.03, and 3 times 0.09, and 4 times 0.25, and 5 times 0.4, etc., etc., etc. Keep going until I get to the end of that list there. And when I do that, I'm going to get a mean value of 4.66. If I do the same type of calculation to find the standard deviation, I get 1.2018. Now, I'm going to encourage you, stop right here. Go back to this previous one. Look at these two formulas. Go through those formulas and try to figure out that these two values are correct. Now, one thing I'm going to point out to you here, just be very careful. When you look back at this formula here, what do you see right here? Give me a pointer. What do you see right there? You see a squared. So when you're actually figuring this, you're finding the square of it. You got to take the square root of it to actually find the standard deviation. Okay? Cool. Okay. Here's a game. If a player rolls 2 dice and gets a sum of a 2 or a 12, he'll win $20. If he gets a 7, he wins $5. But every time he rolls the dice, it costs him $3. The question is this game a fair game? So here's what we got to do. What's the probability of rolling a 2 or a 12? Well, there's only one combination that gives you a 2 and only one combination that gives you a 12. So basically, you've got 2 occurrences out of 36 that give you $20. To get a 7, there are, what? Let's see here. 6 of those? Yeah, 5 of those, 5 combinations that give you $5. And then it's going to cost them $3 every time. Well, I could actually figure this out, and I'm going to tell you that it's not a fair game since the mean value you're going to get here is 1.944, which is far less than the $3 it cost you to play the game. let's see what we can do to figure this out. So um, there are, like I said, 2 out of 36 or 1 out of 18 give you $20. Yep, pencil. Yeah, right down here. 1 out of 18 or 2 out of 36 give you $20. 1 out of 6 will give you a $5 payout. And there's going to 7 out of 9 times, you're getting nothing. How'd I get that 7 out of 9? Well, it's what's left when I take these two. You know, 3 out of 18 and 1 out of 18, that's 4 out of 18. That gives you 14 out of 18 or 7 out of 9 left. You get nothing. And so if I take this p of x times this x, right, add them all up and divide by 3, I will get that the mean is 1.944. Okay? So since it's costing me $3 to play and my average, the mean that you'll win is 1.944, geez, you're not winning as much as you're paying in. You're gonna wind up losing money, aren't you? So no, it's not a fair game at all. Okay? What we're talking about here is really just linear transformation. What we're doing there is we're figuring out the weighted means. Is all we're doing. Weighted mean and weighted standard deviation. But when we take these things and we start talking about finding linear transformations of these random variables, this is usually where I start losing people. Okay? Then what they're saying is if x is a random variable, then the random variable y can be defined this way. It's just a linear combination, linear transformation. I'm going to take the x value times some b and add a to it and get this. So I've got linear relationship between the two variables, x and y. Okay? If I can find the mean of the x value, all I got to do is stick it into the same equation and I find the mean for the y values. Well, that makes sense. If it's a linear combination, if I find the mean of the x's, then I can find the mean of the y's just by using that formula right there. Standard deviation has a little bit different hang on this one, though. They use the absolute value of this b value to find the standard deviation. Okay? And there's no a on this one at all. It's just the same b value, but it's the absolute value of it. So if it was a negative, it becomes a positive. That's all that means. Cool. So the mean is changed by addition and multiplication. The standard deviation only by that multiplication, only by getting to that point. Let's look at where we would use something like this. X is the number of gallons required to fill a propane tank. Suppose that the mean and standard deviation is 318 gallons and 42 gallons respectively. The company is considering a pricing model service charge of $50 plus $1.80 per gallon. They're going to change their prices by this amount. Okay? Well, y is going to be the random variable of the amount you're billing them. What is the mean and the standard deviation of the amount billed? Well, we can take this mean, 318, times the $1.80, add the 50 to it, and we're going to get this 622.40. We can take this mean of 42 times $1.80, and we should get this 75.60. I'm doing it on my calculator just because I want to make certain that I'm not saying anything wrong there, and that's exactly what you get. Okay? Now, if this had been a negative number, minus 180, then it would still be a positive number, and it would still have a standard deviation of a positive 75.60. Okay? Okay. When I'm combining two linear equations together, I can take the means and just add the means together. It works very easily. I can take the difference of those means, and it's just a difference in the means. But the standard deviations work differently. Okay? Whether I'm adding or subtracting the a's and the b's together, I still take the standard deviation, I square it, okay? And I take the standard deviation of the other one and I square it, add them together, and take the square root of it. So it's different. See how I've got a plus or minus right here, but I'm only adding these standard deviations together. I'm not going to do anything different there. Okay? Okay. Just make certain you understand these and you're applying these rules. A nationwide standardized exam consists of a multiple choice section, a free response section. For each section, the mean and the standard deviation are reported to be these type of numbers. Okay? Not unlike what you would see on the AP test. You've got a multiple choice, you've got a mean and a standard deviation. You got that free response, you've got a mean and a standard deviation. If the test score is computed by adding the multiple choice and the free response, what is the mean and standard deviation of the test? You're going to add the means. 38 plus 30 gives you 68. Okay? My standard deviations, I'm going to take 6 squared, 36, plus 7 squared, which is 49. 36 plus 49 is 100, and let's see here, 84? Let's see here, 36 plus 49 is 85. Wow, can't even think. And then I take the square root of 85, and I wind up with 9.2195. And it goes on with a few more decimals, but that'll be enough right there. I found the standard deviation of the overall test just by finding the means of the multiple choice and the means of the free responses and the standard deviations of each. Cool? Okay. Well, this is what I was going to be talking about in Class Connect today. If you have any questions, feel free to send me questions via Kmail. I'll be glad to try to answer them for you. Okay? And I will talk to you next time.